All right, the final lecture of this section, the node architecture. It's important to understand when does node terminate, because I added this lecture specifically because I ran into this case and I thought some people might be interested in it, so that's why I added it. When does node terminate? You see, it all depends on what node is doing. If you don't know what node is doing, you're in the dark. You don't know what's going on. But if you actually understand, it all comes back to the understanding what is happening behind the scenes. You have control. And if anything is important, is control when it comes to a software engineer. So, node. When does node actually terminate? The short answer is it terminates when there is absolutely nothing to do. Absolutely nothing to do. There might sound like there is nothing being done as far as your code is concerned, but there is some stuff that has been spun up as a result of things you did. You just are not aware of it. And my job here is to point you to these things and just show you that, hey, this is what's happening behind the scenes. Have you ever run up node and then you notice that it doesn't terminate? It's possibly because it's still doing something. And what is it doing? It's often related to socket management and networks. That's more like 99% of these cases. So when you call a socket listener, there are things that is being done, right? They're just not visible to you. And then, as I said, like, understanding the fundamentals is like number one priority for a software engineer. Just understand what's going on. Like a socket listener, a connection, reading from a connection, all of this, there are system calls being called behind the scenes. So take an example. This is going to be a short lecture. But once a connection is created, nodes does something to it. Right? In this particular case, we're creating a socket and we're connecting to this example.com IP address, 93.184.1.215.14, okay? And I'm connected to port 80. And if I call connect, which goes to the poll phase, and that will have the socket will be created in the initial phase, but it won't have anything, of course. But then the binding will happen in the poll phase. You know, I think the binding in this, okay, this is interesting. The binding will happen in the poll phase because I gave it an IP address and it needs to figure out what this IP address is. So it will be delayed until the poll phase, and we can test all this to verify. But once the binding happens, there's, hey, I'm binding my client side socket to a server side connection, right? To a server side IP. So that means I want to connect to this IP to this port, and I am a client. I'm a front end. So in this particular case, the first thing we need to do is bind. Hey, create a socket and just bind it. Like, hey, 80 this. And then of course you need to also bind it for the source side, because that's how sockets work. You need to bind it in the source side. What's your source IP? What's your source local port IP, and then what's your source port? And then what's your destination IP and what's your destination port? Most of us are interested in the destination. We're not really interested in the source. So the kernel often generates that for us, the source port. But you have to have it. Otherwise, the connection has to have four things, right? Source port, source IP, destination port. You need four things to uniquely identify a connection. If you don't have four things, you're done, right? So we give it to the other binding will happen at the kernel side. It will give you a random source port, right? Ephemeral one, and then the local IP. Now this is interesting. Which one are you coming? It depends, right? Are you going to a local IP address? Is your destination 127.0.0.1? If that's the case, then you better bind local to a local loopback. Are you going to a network? Then you better bind to a network that matches the subnet that you're going to. Are you going to somewhere completely different? Then you're gonna bind to a network which has a gateway that can get you there. All of the stuff I talk about in my networking course. Capture and feel free to ask questions. It doesn't have to be about Node, right? So guys, if you have a question about network, just throw them here. So I'll answer them. But yeah, so all these decisions need to be made somewhere, right? And cannot be made at the initial phase, right? So it's delayed to the poll phase where more context exists, right? So that's basically it. So once we have that, now that we bind a connection, it doesn't have anything. We need to send stuff. We need to establish the handshake because it's TCP. So now we send a SYN. We actually write to the socket. Writing to the socket happened in the which phase? Poll phase. Correct. And then we're writing the SYN, and then we're waiting, and meanwhile, while we're waiting, we're gonna do we're not gonna block, right? We're gonna just move on and see what Node does. That's why Node is asynchronous, just moves. It's a very brilliant design, right? How they did it. It's like, hey, I'm gonna do that. Meanwhile, I'll just go on my way and do other stuff. So yeah, we'll connect to this stuff and then connect and then do all this stuff. And yeah, we're sending this. And then once we get an actual connection, that's the reason we have it here. We have a live socket. It looks to you like, hey, the code is done. We did a loop and we called end and then we're done. Not really. You have this puppy. This is a socket and this is a live socket. You know what Node does behind the scenes? It calls epoll on this socket. Remember when we talked about the prepare phase, where we take an epoll data structure and we add the connection as a control poll, and then we add it to that connection, to that epoll list. And then we say, hey, kernel, monitor this for me. Let me know if there is data coming for me on this connection. And Node will continue calling epoll wait, epoll wait, epoll wait. And epoll wait in itself, it's blocking, right? But Node is smart enough to not block itself, right? Only when there is absolutely something. If Node knows, like, oh, if there's a timer, I'm gonna block for that timer so I can unblock myself. If there is nothing going on, it will just block and stay there, and that's fine because there is nothing to be done, right? But if there is stuff happening, the epoll wait will be sent and will just be timed. So like, okay, let's block for a few seconds there until we go and do the other stuff here. So yeah, it's just there's always, it's like, hey, okay, give me that. So if there is data, immediately the kernel will say, hey, it's ready. You can call read on it, and you can read on it, you get the data, and then you do that. And as long as the connection is alive, it's gonna continue doing that. And if it's there, it cannot end, and that's why Node remains running. Same thing with the server. If you're listening, then we need to do epoll, but this epoll is not for reading socket connections. No, this is a server listener. So it waits for connections to be received on this socket listener. And when there is a connection, epoll will tell us that, hey, there is a connection, go call accept. And it will call accept on it. And we'll just do this over and over again. If there is no connection, we'll just block, of course, unless there's something to do. But yeah, Node will continue running otherwise. Unless you close the server, like we did here. If you close the server, you close the socket itself. Like I think I closed the socket here. Yeah, I destroyed Yeah, this is here is called destroy, and here is called close. I don't know why it's different, to be honest. But yeah, it's a different object. Like create server is a server object. It's not a socket. But although behind the scenes they are sockets, right? So yeah, guys, this is it. Node looks like it's not doing anything, but it actually is. Sockets and connections. Let's do some example. How about we do some example here? I'm gonna do node. This is our example. Yeah, I write all of this, guys, for you guys, like a lot of details if you want to read through this. But yeah, we're calling read, we're calling receive system calls, all sorts of stuff happening behind the scenes. So if I do as trace, you'll see is tons of system calls continuing going on. Node, yeah, let's run this. 120, 12, 120. Yeah, node is running. It's gonna continue be running until basically, I think after 5 seconds, it's gonna close itself. Yeah, that's what I did. Okay. And same thing with the listener socket, right? Look at that. We're listening on a socket, and we can just wait for after 4 seconds, it will just destroy itself. But yeah, if I don't have this timeout, it will just remain basically forever until node dies. Right, so we'll receive that, and you want that, right? You want that. You don't want, because you want that server to be running all the time to accept future connections, right? Yeah, so it's interesting. I guess here's what I'm gonna do. I'm gonna do this on my Ubuntu machine. Here's what I'm gonna do. I think I'm gonna do an strace -f-t timestamps. I'm not gonna do an output. I don't know if I can do that, to be honest. I wanted the output to be on the std output here. Let's do that. 12 exit 12.0. Oh, why do all of a sudden I need to do a sudo? I never had to do a sudo here before. Oh, yeah, it doesn't work. Oh, wait a minute. Wait a minute, I forgot. I had to do node. Oh yeah, it works. How about that? See? Look at that. This is actually this is powerful, you guys. Look at that. When I did strace, oh, this is perfect, guys. I'm glad I did that. Did you see that? We blocked at equal wait. We just blocked there. And then we stayed there for that long until the connection has been closed, right? So it works. I can print it to this. So let's go ahead and then do this. Node. I'm gonna remove that timer, right? And here's what I'm gonna do. Actually, I'm gonna do the other one. Node exit 121, and I'm gonna remove the server timeout because I'm listening on port 8080. That means anyone can connect on port 8080. Hopefully I have that. So node 12. No, I do an strace, right? Strace node, and then do that. Look at that. We added these. We're in the prepare phase. Now we're blocked, guys. Node is completely blocked on the ePOL case. Here's what we're gonna do. I am going to open another one, but I want to. Here's what I think. I want to make this a little bit tiny. I want to make this tiny so you can see both screens. Cool. So let's do this. So I'm gonna do telnet 192.168.7.179. Hopefully that's my IP address. Do you see what happened? Did you see what happened? Yes. This is the bind. We binded this guy. We blocked right here, and then I came in sigwinch. I have no idea what sigwinch mean. We got equal wait, read, equal wait. I'm looking for the except because we're going to see an except soon here. I blocked 39 until I got a beautiful except here. Do you see that? Equal blocked us, and after a minute or whatever, we got an except. Because that's what we have. So let's capture the time. I'm blocked again at 19:23:11, right? All right, let's do another connection. Except. And then we added it in the prepare phase, right? 21. Let's do another one. Let's quit. We shut down. We shut it down. We delete it from the equal. Let's do another one. Boom. Isn't this cool, dude? This is so cool. You can see what's happening behind the scene. As I'm expecting, see, I'm calling equal wait. So Node is doing so much stuff here. I mean, Node is the only job here. Node is just doing a web server. Like, assume you have like a background task that you're doing like with timers to do things. Then you'll see more and more stuff happening, right? But here, we're closing a connection, and then I can just do this, right? I can just create another one and says, hey, let's do two connections, 192.168.7.179.80.80. Boom. Another add. Now it's 22. I'm adding 22. Telnet. Another one. 23. What happens if I send something? See, I'm reading. So what happened if you sent something, and that's what I'm talking about, you guys. We're doing equal wait on the connection and being blocked because there is nothing on the sockets. There is nothing on these connections. But then someone sends a data like, hey, I sent something, AI, right? I don't know why I picked AI. Then we immediately get unblocked. The equal wait returns and says, hey, there is data. There is one connection that is ready. Oh my God, I'm blocking you. I'm blocking you guys. Yes, there is one data that is returned. Okay. And then you can see that, hey, go ahead and read it. So what will happen is Node will issue a read, a system call read, and this is what we're going to get back. And it's issuing, that's a large buffer, 65K. So, dude, it's like Node is naked. You can see everything. Isn't this cool? Not the fact that Node is naked, but you see my point, right? I love this stuff so much. Like, send something here. Send something here. And you can see, look, we're reading on which connection. We read on 23. We're reading on 21. We're reading on 22. These are three different connections. Right? And what if I send something really large? Let's send the work of Shakespeare. I have no idea what I'm doing, you guys. Works of Shakespeare. Oh my God. Oh, a lot of you guys. It's like, what is he doing? Dude, this is so cool. Yeah, no, just stopped replying. It's just like, yeah, this is silly. I'm not going to read. Yeah, I think it's just waiting. Yeah, now hit enter. I wouldn't be surprised if the connection got closed because I'm just sending so much stuff. All right, guys, I'm going to stop right here. But we proved the point, right? This is so cool. This is definitely something you can play with, guys. And continue. See, but yeah, look at that. It looks like it was removed altogether. Yeah, the connection has been removed. Specifically deleted for some reason. So I guess the connection is closed. That's what happened. I don't even know what happened. But yeah, clearly it has been deleted, as you can see. All right, guys, that's the end of the lecture, and I hope you enjoyed it. This is so much fun. You're going to see this all over, but we're going to learn a lot as we go through this stuff, right? I encourage you to do the same thing and experiment and see what's going on. But at the end of the day, it's just, just code. It feels so good when you understand. See you in the next section, actually.